Thanks for joining me around the virtual telescope again. Up next, the lone wanderer, the supernova that couldn't find its way home. As visual observers and imagers, when we usually go to see or image supernova or hunt for them, we usually do it in the busy star-filled regions, neighborhoods of galaxies. We look at the dust lanes of Messier 51 or the spiral arms of a galaxy like NGC 6946 or similar galaxies because that's where the action usually occurs. That's where we're going to usually find supernova. But SN 2024 ABVB decided to do something completely different. It exploded in the middle of nowhere. You can see in the image here that I have above on the right hand side, you can see the supernova going off. You can see its host galaxy down to the right below it. It is far out from that galaxy. This event is what astronomers call a Type Icn supernova. I haven't talked about that. We'll talk about it briefly here. And it's one of the rarest breeds in the cosmic zoo, so to speak, in the supernova clientele. Here's why this specific blast has shaken up our understanding of how massive stars live and die. The impossible location, SN 2024 ABVB, was found 22 kiloparsecs, that's roughly 73,000 light years, from its host galaxy. To put that in perspective, that's like finding a campfire out in the middle of the desert, miles, hundreds of miles away from the nearest town. Like where I go observing, if I see a light in the distance, a campfire or other lights, usually late at night, that gets my attention in the middle of the week because I'm the only weird one out there observing at that time. So it kind of gets your attention. Does that make sense? It kind of shows that this supernova was an extreme offset, making it a true stellar outcast. It was stripped bare. Most supernovae are surrounded by hydrogen or helium. Those are the first elements that a star will burn through. Type Icn events are different. They're stripped. The star lost its outer layers of hydrogen and helium long before it blew up, leaving behind a core of carbon and oxygen, the next layers. When the star finally collapsed, the explosion slammed into a shell of carbon-rich material it had previously coughed out, creating a radio scream and a very specific spectral signature. The runaway theory, since massive stars don't usually form in the empty outskirts of space, how did it get there? The paper suggests this wasn't a lone giant. Instead, it was like most stars in our universe. It was a part of a binary system. Most stars are in a binary. There's two of them in orbit around each other. A companion star vaporized its outer layers, stripping it down to its carbon-oxygen core. During this violent process, the star was kicked out of its home galaxy at a high speed, traveling for millions of years before finally reaching its breaking point in the intergalactic void. Even though it was a stripped star, which usually means a smaller explosion. SN 2024 ABVB was actually incredibly bright. It was one of the most luminous Type Icn events ever recorded. It challenges the idea that you need a massive, intact star to create a brilliant fireworks display. Why does that matter to us? Well, when we're looking at the eyepiece or imaging and we're looking at a faint fuzzy galaxy, we tend to focus on the core and the bright arms. This discovery is a reminder that empty space around those galaxies is just as full of drama. There are stars out there far from the safety of their home clusters, ending their lives in a spectacular, lonely fashion. The next time you're scanning in the suburbs of a distant galaxy, visually or imaging, remember SN 2024 ABVB. The universe is full of wanderers, and sometimes the best shows happen where no one is looking. Clear skies to you. Thanks for joining me. We'll catch you next time.